Oh, I am very curious to hear from our next speaker because imagine what happens when 30 developers descend on San Martin de los Andes for 3 days. What are they doing? What are they hacking? What are they talking about? I don't know about you, but I am dying to know. Our next speaker will reveal just that. Please welcome to the stage Barnabé Monnot.
Hey. Hello. Yeah, good to be here. Thank you for attending the talk. I want to tell you a little bit about some work that we did last week in Patagonia at Edge City on the Open Intents framework, which is an interop stack that is very modular, very extensible, and very valuable for the Ethereum ecosystem. Okay, so last week we were basically entrenched in this hotel room, hacking away on many fun projects, trying to kick the tires of the emerging Open Intents framework. We are lucky to have over 30 builders from these amazing companies. And throughout this talk, I want to give you some quotes from what they had to say about the event, because I feel there was such a great connection. The human element of this experience is really important to me. So weeks like this remind me how rare it is to find deep alignment, technical focus, and humanity in the same room. So I think we really had something very special there, and we want to show you how that translates to the Open Intents framework as a stack. So by the end of the week, we managed to get through 7 projects, which are listed here. And I'll get into them in a little bit. But let's first rewind a little bit and understand what the Open Intents framework is and what it's trying to achieve. So the Open Intents framework started as a collaboration between many companies, including the Ethereum Foundation, Across, LeFi, OpenZeppelin, Wonderland, Hyperlane, Arbitrum, Uniswap, Coinbase, and many others. I'm reading from the notes because we have so many great partners that I didn't want to forget any one of them. Why are we building this stack? We want to make interop accessible, and we want to meet the users where they're at and try to uplift the ecosystem with a modular set of components. The idea of OIF is to provide these turnkey intent-based bridges for new L2s. So it should be very simple for anyone to just deploy that and be connected to the Ethereum network when they launch a new chain. We want to design OIF so that we don't have any vendor lock-in for apps and wallets, and we have standard tooling. So you don't have to be opinionated about single solution that you are picking. You leave the choice to the user. We also want to build this stack to bridge different protocols that have different pools of liquidity, as we believe this gives you better pricing, better latency, and just simpler intent-enabled UX for users. So these network effects are very important to make intents a great cross-chain UX solution. We're also building it very modularly, in particular the settlement. So how much trust do you need to have in the components of the system? You can be pretty extensive with this, and in particular, we are building trust minimized components to have fully trust minimized interop with intents. And the last thing the stack aims to achieve is to simplify the operations of solvers and fillers. In particular, today's solvers, they have to custom integrate every single interop protocol. With this stack, there's a legible interface that they can just conform to and, yeah, be plugged into the market immediately. Here's another quote. I played around with the contracts and was pretty impressed with the modularity it provides. Different settlement paths can be easily swapped in and out depending on the trust assumption the user is comfortable with. So what is OIF? It's a full stack framework for intent-based cross-chain interop. In particular, these are the 3 main components of the OIF stack. So there's a suite of contracts, there's something called the aggregator, and there is a solver implementation. Another way to think about it is the contracts are there. They are Solidity contracts that you just deploy on the source and destination chains. And they are the contracts that ensure that the fair exchange is performed between the user and the filler. So the user puts funds in the contract on source, the filler puts funds on the contract at destination, and there's another contract that does the settlement to ensure that the fair exchange proceeded fairly. You can think of the aggregator as something like a matchmaker, so the user can talk to the aggregator, it can be run locally, it can be run remotely. That basically helps the user like find the right quote to send their intent to be filled. And then you have a solver, which is the counterparty that manages their inventory, that fills the user intent at destination. There's other parts to this universe. So something that's pretty important is the interop SDK. So if you think of OIF as the engine, the interop SDK is kind of the wheel or the interface, like the access control to this suite of components. And the SDK should contain interop addresses as well as cross-chain operations. So it should allow you to plug in to cross-chain protocols such as OIF-supported protocols. In fact, the module of interop address is available now. So you can already use two types of addresses, ERC7828, which is a human-readable interoperable addresses. So you can write barnabé.if at Arbitrum, and this will be legible. It will give you like the right chain-specific address. And there's also 7930, which is the machine-readable version, which is the binary format of this. So you can already use this and integrate it with the module that's here. Another part of OIF that composes really nicely with the stack is ERC7683, which is a standard for liquidity order. So with this standard, it makes it easier for solvers to compete and to plug into the market, which means that you have deeper markets, deeper liquidity pools, and that means you have cheaper fees, lower latency for users that transit over this. You can see a diagram here. The user will receive an order from the market, will sign the order, and then the order will be filled by the filler that then settles it with a settler contract. So it's a fairly simple flow. Right, so that was a few words on OIF and the stack and components that relate to it. Now I want to talk a little bit about what was built in Patagonia on top or with the OIF stack. So our goal coming into this week was to have an end-to-end demo of OIF, from the user being on an app to the wallet, showing some kind of legible cross-chain operation to the user for them to sign, to the order being broadcasted to the network of solvers, to solvers then performing the fill, so filling the user funds at destination, and then to the settlement that ensures that the fair exchange between the user and the filler proceeded correctly. By the end of the week, we had these 7 different projects, which were chaotically related as per this whiteboard. And I think it was really interesting. Basically, what this quote says, once everyone started hacking, IDs basically turned into prototypes instantly. The pace was wild. And I think this is very much due to the fact that the OIF itself is so extensible, has been really designed with modularity in mind, making it like very easy to just start hacking and customize it to your needs and the needs of your protocol and users. So we had these 7 projects. They're not end-to-end yet, so the thing that we haven't finished by the end of the 3 days is what's highlighted here in the red rectangles. We still need to connect these components together, but we're hoping to make some progress on that asynchronously in the next weeks. All right, so the first project that we had was to have an app, a cross-chain app, that will make use of OIF components and interop SDK. So in particular, we built this payment request app. So somebody asks you for funds, says, please send me 10 USDC on Arbitrum, for instance, using the interop addresses, so ERC7828, so like Barnabé at Arbitrum, as well as the payment request ERC7856. Once the payment request is made and the user signs it, the payment is made over OIF. So it transits over like the pipes of the OIF supported solver and aggregator. One part that was not so easy to build is that you want the exact amount to be received. So if I request $10, I want to receive $10, not 9.96. And so you have to account for the fees for the sender to send like the right amount at the source. And yeah, this is something that was done. I have a little video. Oh. Not sure, maybe it's not in there. That's all right. I think the video didn't make it to the slide. Okay, so that was the first project, a payment request app. The second project that we had is one of our builders actually does this website called vaults.fyi, which is a curated list of all the vaults where you can deposit your assets across many different chains. And one pain point that this builder found, they wanted their users to be able to send funds very quickly, let's say from an Arbitrum vault to a base vault, but they don't want their user to leave the app. Like they wanted that to be just seamless. So how do you make sure that you can integrate components that allow, let's say, the wallet to tell to the app that the user has these funds and this action can be processed? And so what we ended up building is these types of complex flows where maybe you have an action on source, then you want to bridge your funds to another destination, and then you want to take action on destination. But all the time that you do this, let's say you exit the vault, you want to swap your assets, send them around, there's a lot of slippage and fees along the way, and you don't want to like leave dust in many places. And so what you want to be able to do is dynamically inject the values of the outputs that you get as inputs to the next step of the process. And 7683, the liquidity order standard, makes that actually very simple to do at runtime. And so they were able to code like this end-to-end flow, where every time the inputs matched the outputs from the previous step. My clicker is not clicking. All right, I think we're back. Thank you. Okay, so that was the second project, having the ability as an app to create these complex flows with 7683 and send them over the OIF stack. The third project that was attempted was trying to repay the fillers that provide the funds on destination as quickly as possible using TE proofs. The person who wanted to build this project was looking to replace a custom integration they had made with Across by integrating OIF instead using their TE Oracle. That actually took them longer to remove all the custom stuff that they had to build to integrate Across. And I think this shows that something that doesn't have this vendor lock-in that allows you to perhaps decide on different protocols depending on the needs that you have, either in time or per user, is very attractive to app builders who want to enjoy this optionality. So I would say bonus points for OIF here. The fourth project that we had is ERC 7683 compliant Rails. So 7683 is like a standard order, but you may still need to translate data from specific interop protocols into the right format that makes them legible to the solver so that the solvers can compete on filling these intents. So to do this, you would implement a resolver, which is a contract that performs this translation. And that makes it that any solver that complies to the 7683 interface will be able to read orders that come from this protocol. In particular, the team that worked on this, led by Frangio, they used a new version of ERC 7683, which is V1, which is an upgrade from V0. At the same time as I'm giving this talk, they're giving a talk about what this new version contains. So please catch the replay after this. Another quote, if you care about seamless cross-chain transactions, keep an eye on the standard 7683 and consider contributing. I think it's a very important standard to try to widen the market and make it as accessible as possible. Our fifth project had to do with settlement. So we wanted to build an Oracle, a settlement that was as trust minimized as possible while being efficient. What we opted for is an optimistic game for the settlement, where in the happy case, the solver attempts to claim the funds, and if there's no dispute, the funds are just given to the solver. In the unhappy case, somebody can dispute this claim, and the challenge gets resolved using the trust minimized broadcaster, so basically the canonical bridges of the rollups, to resolve the challenge. So to decide, did the solver actually fill the user order or did they not? We went a bit further. Someone else attempted to try a more complex optimistic game, which is 2 stages. So in the happy case, again, no dispute. The solver actually claims the fund legitimately. In the first unhappy case, when there's a challenge that gets triggered, you can resolve the challenge using a TE proof. But again, that proof can be challenged. So if the TE proof itself is not right, somebody can challenge it, and then you go back to the trust minimized settlement using the broadcaster. That can take up to 7 days given the canonical bridges on optimistic rollups. So you can really make an OIF flow as trust minimized as you want. The 6th project, oh, all right, thank you. The 6th project is the ZK proof of fill. So given that we obtain settlement, we want to prove that a fill is valid using a ZK proof instead of a storage proof. So storage proofs are just fairly gas expensive, and you can amortize the cost by passing a ZK proof to show that on destination, the fill of the solver is valid and is legit. So the person that worked on this requested a proof from the boundless network, and that's what happened. Okay, the 7th project is Rioli. That was built by very enthusiastic people who wanted to think about agents, who don't have liquidity on chain for every action, but they want to request services across chain. So you have your agent, which is on Arbitrum. They want to do something for you on Base. They have to find funds on Base to be able to perform this. So here they use the resource log protocol, which can also be part of the OIF stack, creating access for the agents to access passive funds on destination. They use the TESV allocator to ensure that there's no double spending. That tells you whether the resource can be spent or not. That's why it's locked in the first place. So I want to end with a bit of a call to action. Like, these are the 7 projects that we built. I hope they show the breadth of things that can be built with OIF, and in particular how quickly you can get started with it and build like just really valuable components or apps on top of this stack. We're really looking to talk. Like, we want to understand better the needs of different categories. So for instance, if you're an app with cross-chain needs, we want to talk to you about the interop SDK. We think that this is something you should be looking into integrating if you just want to have access to this interop stack. If you're a wallet, there are many different components here as well. The interop SDK, again, should support many of these needs, in particular interop addresses, something that can be very nice for your users to orient themselves across chains. If you're an intent protocol, we want to discuss about the OIF contracts themselves, as well as ERC 7683. We think like the more integration we have on these open interfaces, again, the deeper the markets, the better the users are. For solvers, we want to talk about 7683, as well as solver operations. Like, we think some of the stack that we have, in particular the solver implementation, can be just very easily reusable and extensible by current players. And if you're a chain launching on Ethereum, we want to ask you about using the OIF contracts as well as deploying a solver to ensure that your chain gets out-of-the-box connectivity with the broader Ethereum ecosystem. So these are our Telegram handles. I'm Barnabé Monnot. I work a lot with Josh Rudolph, so please reach out. And I want to end also by saying thank you to the amazing builders that were part of this experience in Patagonia. Thank you.
Actually have time to take a question, so let's step over this way while we make sure the next speaker is set up. So if you guys have not noticed yet, there is a QR code that appears on the right of the stage, so you can scan that and ask our speakers anything you would like, and if we have time, we will take questions. Now, Barnabé, this question for you says, we built a testnet app on OIF. How can we best connect with LPs, market makers, and individuals running solvers? Is there an obvious way to plug into them? And what if we have custom OIF interface requirements?
Yeah, I think the best for you, I'm not sure who you are in the audience, but would be, please reach out to me. I'm happy to chat. On the other stage, at the same time, we have Pepe from OpenZeppelin, who's working a lot on solver integration and market integration. I think he might be the right person to have a chat with. It should be very easy to plug you to the Open Intents Framework market, to the solvers, to the 7683 interface. yeah, and if it's not, we should understand why, because that's what the question asks. I think is really the point of YF in the first place, to make it like almost a no-brainer to plug yourself to this market, and for your app to suddenly obtain like all of these cross-chain capabilities under the hood.
Now, another question that someone asked from the crowd is, how can I join next time and hack and build with you? So what do people have to do to be there with you?
Yeah, I mean, we had an open call on Twitter. We had many people who joined. I didn't know them, but I was very happy to get to know them better through this experience. So, I don't know, follow me on Twitter. I really hope that we get to do this again. I think it was a very productive experience. Yeah, stay aware of like our next call for invitations to such events, and reach out in the meantime, of course.
So I guess the best way is to follow him on Twitter and see when there's an opportunity. And don't be shy. Talk to Barnabé. You can see he's a nice guy. He won't bite. Thank you so much, Barnabé.
Yep,
Thank you
thank
very
you.
much.